Alright, we are in section 7.1, ratios and proportions. So let's look at problem 1. So problem 1, the bonsai bald cypress tree is a small version of a full-size tree. A Florida bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the Senator? So the height of the Senator is 118 feet. So Senator is 118 feet, and the bonsai is 15 inches. And that means that we got two different units here. We got feet and inches. So let's convert 118 feet to inches first. So how we do that is 118 feet times 12 inches over 1, so that gives us 1,416 feet. So we want to know what's the ratio of the bonsai to the Senator. So if 118 feet is 1,416 inches, and the bonsai is 15 inches over 1,416 inches, and that is going to equal 5 over 472. So that is the ratio, or how some people write it is 5 to 472. So remember, we converted the feet to inches first, and then we divide. So Charlie got it down here. See, yep. All right. Number 2. Okay, so yes. All right. Number 2. Members of the school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. They plan to buy 120 pots of flowers. The ratio, the number of tulip pots over the number of daffodil pots, will be 2/3. How many pots of each type of flower should they buy? Alright, so the ratio we have is the number of tulip pots to the number of daffodil. So that's 2/3. So the number of flower pots we want to know. So that means that we're going to let x equal the number of pots. So that means we have 2x plus 3x equals 120. So we look back here. They could buy 120 pots of flowers. So we got 2 and 3 right down here. Alright, so now we're going to solve for x. So 5x equals 120. So x equals 24. So now that's how the number of pots. So to find the number of tulip pots and the number of daffodil pots, we're going to do tulip is 2 times 24, which is 48 pots, and daffodil is 3 times 24, which is 72 pots. So that's the answer for. So you want to see the work right there, and try to got it down here. Alright, so number 3, we're going to use an extended ratio here. So the lengths of the sides of a triangle are in the ratio 3, 5, 6. The perimeter of the triangle is 98 inches. What is the length of the longest side? So you can see right there, it's a 3, 5, 6 ratio. So what we want to do, since the perimeter equals 98, and the perimeter is the sum of all the sides, we're going to do 3x plus 5x plus 6x equals 98. Solve for x, which is 7. So when we solve for the longest side, it's going to be 6 times 7, which is 42. So we added all the sides together, summed it up to 98, and then we solved for x. And then we plugged x into the longest side. So try to got it down here. Alright. Problem 4, you know, it is what is the solution to each proportion. So let's just look at letter A. Solving for 6 over x equals 5 over 4. Cross multiply. So then that's 6 times 4 and 5x. So 24 equals 5x, and we solve for x. So try got it letter A. Alright, and then final one, number 5. Paper. We want to know, so in the diagram, x over 6 equals y over 7. What ratio completes the equivalent proportion x over y equals what? So if you look over here, you want to see what corresponds to what. So I look at the picture. X corresponds to 6 and y corresponds to 7. So therefore, for number 5, I'm sorry. So since they set it up as x over 6 equals y over 7, x over y equals 6 over 7. So that's how I did it by looking at the picture. Now, to look at it without 1, you can simply solve for x over y. So that's method 1. Method 2 would be cross multiplying. So we're left with 7x equals 6y, and then we're solving for x over y. So then divide each side by y first. So then we're left with 7x over y equals 6, and then divide by 7 on both sides. So x over y equals 6 over 7. So this is if you don't have a picture. You can solve it algebraically, or you can solve it visually. So, got it letter A. Just right here.